right, so here we're on 6.4 on maximization and minimization with mixed problem constraints. So we're going to introduce the Big M method. We're going to do Big M method. Then we're going to have minimization of the Big M method, summary of solutions method, and then larger problems, which is the refinery applications. So what is the Big M method? Well, we have three types of variables. We have slack variables when they have constraints less than or equal to, and those are going to be some SI. Now, we're going to use surplus variables, and that's going to be the amount the left side exceeds the right side for constraints greater than or equal to. So for less than or equal to, we use SI. Greater than or equal to, we're going to have a non-negative like a slack variable, and we're going to subtract it from the left side of the equation. So it's going to be some S sub k. And then there's also going to be something called an artificial variable, and that's going to be used when the surplus variable is introduced. Has to be non-negative constraint. You add it after the surplus variable, and then a penalty is subtracted from the objective function. So we're going to have some m sub a, maybe 1, and m is going to be a huge number, like 10 to the 6th or something like that. So whenever you're thinking about this, m is always going to be a very large positive number. So that's kind of a key because when we're doing these, you're going to see, m minus 7, and you're going to think, oh, it's a negative. No, if m is 10 to the 6th, 10 to the 6th minus 7 is still a positive number. So that's a thing you're going to have to think about when you're doing some of these problems. All right. So what we have here is kind of how a problem might be set up. Notice we have the less than or equal to as well as the greater than or equal to in our constraints here. And so what we have to do is we have to think about what we're going to do. All right, well, first we're going to make a modified problem. So let's kind of do this and say the modified problem. And so what we have to do is we're going to have some kind of max p is equal to 2x1 plus x2. We're going to leave a space here because I noticed that I have this, which means I'm going to have to add in this some surplus variable as well as some objective function. So I'm going to add something up here in a little bit, and it's going to be subject to. And now, because I have this less than or equal to, I'm going to have to add in a slack variable. So I'm going to take x1 plus x2 plus s1, and now maybe I should write this in a different color. And this one is a slack variable, and that's going to be equal to what, 10. And then I'm going to have the next one, which is going to be a minus x1 plus x2. Now I'm going to add in I'm going to have to, well, subtract off, I should say. I'm going to subtract off a surplus, but then I'm going to add in an artificial. So I'm going to subtract off an S2. I can't call it S1 because now it's S2, but I'm going to add in that artificial variable, and that's going to be that. So now we have two more things we've just done. We've added in this one, which is going to be our surplus. And if I could spell, and this is artificial. Okay. And now up here, I'm going to add in my other piece here, the kind of the after the surplus, we add in this penalty. And so now my penalty is going to be what? Well, it's going to be subtracting off MA1 because I had one artificial variable. So I have to subtract that off of my penalty up here. Now, what do I know? Well, I know that x1, x2, s1, s2, and a1 all have to be now greater than or equal to 0. So that's modifying the problem for the going from the less than or equal to, greater than or equal to the equals to by adding a slack, a surplus, artificial, and subtracting off the penalty here. And now I'm going to go to the initial system. So this is kind of the way we're going to do this. And we're only going to start this and we're going to say, oh, well, now we have to test the preliminary tableau. So first we'll do the initial system. Well, what's that going to be? Well, that's just going to be x1 plus x2 plus s1 equals 10. Then we'll have a minus x1 plus x2 minus s2 plus a1 equals 2. And then we'll have, now we bring all that over to the other side. So now we've got what? A minus 2x1 minus x2 plus ma1, then plus p is equal to 0. And again, we have all the x1, x2, s1, s2, a1 greater than or equal to 0. All right, so that's kind of my initial system. So basically, I've taken the objective, solved it for zero, put it down here, and then I've just brought those things down here. So now what we're going to do is we're going to go into something called the preliminary simplex tableau. Now, if you remember from the last section, we went to the initial tableau, but now we're going to a preliminary because we have all these weird things. We have this M and A's and stuff. So we have some stuff to do. So my preliminary tableau, and I'm just going to write across the top. I'm not going to write anything down the side because what's going to happen is we're going to end up having to do some pre-work before we can actually have a simplex tableau. So that's going to be what a one, 0, 0, 0, and then 10. That's going to be a -1, a 1, 0, oops, a -1 here, and then a 1, and then a 0 and a 2, and then I'm going to have what a -2, a -1, and then I'm going to have 0, 0. Then I'm going to have an M, and it's going to disappear here probably, and then a 1, and then we'll have a 0. All right, so notice I didn't put anything out in front here, so we're not going to really label our rows yet. So what this is our preliminary simplex tableau. So now what do we do with that? Well, what we do with that is we have to actually go and look at the definition of initial simplex tableau. So like I said, we're at a preliminary now. Now, does it actually fit our definition of the simplex tableau? So for a system tableau to be considered an initial simplex tableau, it must satisfy the following two requirements. The requisite number of basic variables must be selectable by the process described in section 6.2. So we did that already, so we can do that. Now that is, a variable can be selected as a basic variable only if it corresponds to a column in the tableau that has exactly one non-zero element, and the non-zero element in the column is not in the same row as the non-zero element in the column of another basic variable. Okay, and this will make more sense when we kind of get back to what we were just looking at there. And then the remaining variables are then selected as non-basic and to be set equal to zero in determining the basic solution. And then the basic solution found by setting the non-basic variables equal to zero is feasible. Now, if both 1 and 2 are not satisfied, what we have to do is some row operations to transform the preliminary tableau, which is what this is, into one that actually satisfies both of those. Now, this is not going to be a pivot operation. That's why I say don't put any emphasis on S1, S2, all that stuff, because we're not doing pivots yet. And what we need to do is we need to eliminate M in bottom row of preliminary simplex tableau corresponding to an artificial variable. That will give us then initial simplex tableau. So if we have M in an artificial row, well, guess what? Here's artificial row. We have an M here. We need to get rid of that. And so that's the key thing. And sometimes you're going to have two or three artificial variables, and there's going to be an M in each one of them. And so we're going to have to do a lot of different operations. So we have to make the row operation to say basically a minus M times this row plus this row to get this to be a zero. So the artificial variable has a zero down here is what we need to get to be working at this point in time. So that's what we're going to do. This is what we're doing. And so let's go back to our tableau, our preliminary tableau at that. And so we had what? We had X1, X2, S1, S2, A1, P, and then we had a 1, a 1, a 1, a 0, a 0, a 0, and then we draw our thing here, and then we had a 10, then we had a -1, a 1, a 0, a -1, a 1, a 0, and a 2, and then we have our dotted line, and then we had a -2, a -1, 0, 0, M. Here's where we have to do our work. And then we had a 1, and then we had a 0. So what we're going to have to do is we're going to have to take a minus M times row 2 plus row 3, and that's going to be our new row 3 because the artificial variable can only have the 1 here. It can't have something else below, and basically we can't have the M. There's the key. And so we do that, and so if we are lined up perfectly, we don't have to write it again. So I'm going to leave it as it was. So 1, 1, 1, 0, 0, 0, 10. And then I'm going to have a -1, 1, 0, -1, 1, 0, 2. And then my last row is what's going to change. So minus M times a -1 is M minus 2. So that gives me m minus 2. Now we have a minus m minus 1. So minus m minus 1. And then we have just 0 minus a minus is plus. So that's just going to be m. Minus m plus m is going to be 0. Now we have the artificial variable has a 0 here, which is what we want. And then we have 0 plus 1 is 1. And here we have a minus 2m. And so that gives us a minus 2m. All right. So at this point, what do we have? Well, at this point, we have, if we look up here, the x1 is going to be 0, our x2 is going to be 0, and s2 is going to be 0. Okay, because now we have that, so we can't have that. And so now what do we have? Well, I have a1 is equal to what? Well, a1 is equal to 2. A s1 here is rather equal to 10. And then we have P is equal to negative 2m. Okay, so these are non-basic. These are basic. And is this a feasible solution? Basically, is everything positive or whatever? Well, this P can be negative, so it doesn't have to be only positive, but those kind of do. And so this does work out. So this is basic and, if I can spell feasible, this is basic and feasible. Therefore, we go back here, has to be feasible and also has to be everything set up with it being to be basic. And so we have everything like that. Basically, we don't have artificial variable equaling m. Anything else can be an m, but the a cannot be an m. All right, so at this point, now what we can do is we can say, okay, well now let's start our pivot operations with this table. So I'm going to rewrite that table on the next page, and then we can start doing our pivots. And okay, so I'm just gonna say here, start pivot operations. All right, so going to the next page. Again, let's rewrite what we have. We have x1, x2, s1, s2, a1, p, and now we have s1, a1, and p. And so S1 was again 1, 1, 1, 0, 0, 0. And then we had a 10. Then we had a minus 1, a 1, a 0, a minus 1, a 1, a 0, and a 2. And this was M minus 2, a minus M minus 1, a 0, an M, a 0, a 1, and a minus 2M. All right, so now we have to think about in our area down here, our indicators, is which one's the most negative. Well, remember, m is a huge positive number. Minus 2, that's huge positive. Minus that, well, minus the huge positive is going to be a huge negative. Minus 1, it's going to be even more negative. So that one would be our most because the others are all, positives. And so that's going to be our most negative. So now what we can do is find our quotient, and we're just going to write everything out. We're going to take 10 divided by 1 is 10. 2 divided by 1 is 2. That's the smallest. And so because of that, maybe we should circle our pivot element with red. Okay. So that's our pivot element. And so what do we need to do to get everything else in that column to be 0? Well, we're going to take a minus row 2 plus row 1 equals row 1, or is going to go to row 1, I should say. And then we're going to have to take, it looks like what? M times m plus 1 times row 2 plus row 3 to go to row 3. Because if we have m plus 1 times that plus this, those go to 0, so we should be good there. All right, so now let's do what? Well, this is going to enter. This one is going to exit. So we're going to have now S1, X2, P, and we're going to still have X1, X2, S1, S2, A1, P. And so second row stays the same. So we're just going to do that. Now we're going to take a minus this row plus this row. So that's going to be what? A 2. It's going to be 0. It's going to be a 1. It's going to be a 1. It's going to be a minus 1, a 0, and this going to be 8. Now we take m plus 1 times this row and add it to that. So it's going to be a minus m plus m is 0. That's going to be a minus 1 minus 2, so that's going to be a minus 3. That's going to give us 0. That's going to give us 0. That's going to be minus m minus 1, so that's going to be a minus 1. That's just going to be m plus 1. That's going to be a 1. And that's going to be 2m plus 2, so that's just going to be a 2. All right. So now the most negative. Well, now there's only two possibles, and it looks like this one is going to be the case. Now, this is a negative, so that means that the 2 has to be our pivot point because we can't have a negative as a pivot point. So with that said, what are we going to do? Well, I'm going to first take a half a row 1, not 2 there. Half a row 1 and replace row 1. All right, so with doing that, I'm going to have the following. I'm going to get, again, we're going to have just not replacing rows yet. So that's still S1, X2, P, and then we'll have X1, X2, S1, S2, A1, P. And so then we go and draw that in. And so now we've got the 1, and that was a 0. Half of that's going to be a half. Half that's going to be a half. Half that's going to be a minus a half. That's going to be a 0. Half of 8's 4. Then we had a minus 1, 1, 0, minus 1, 1, 0, 2. And then that was a minus 3, 0, 0, minus 1. That was m plus 1. That was 1. And that was 2. All right. And again, if we put this is our pivot, so now we need to make those to be 0. So how do we do that? Well, if we take row 1 plus row 2, and that's our new row 2, that'll go to 0. If we take 3 row 1 plus row 3, that'll be our new row 3. All right. So, and this one is enter, and this one is exit. And so now we have x1, x2, p. We have X1, X2, S1, S2, A1, and then we have a P and that. So first row stays the same. Add that to that, it's going to be 0. That's going to be a 1. That's going to be a half. That's going to be a negative a half. That's going to be a half. That's going to be 0, and that's going to be 6. Now 3 times that plus that's going to be 0. That's going to be 0. 3 halves is going to be just 3 halves, I guess. And then that's going to be 3 halves minus 1. So that's going to be a half. And that's going to be negative 3 plus, so that's going to be m minus a half. That's going to be a 1. And 3 times that's going to be 12 plus 2, so that's going to be 14. All right. So now notice our indicators are all positive. So we're going to stop because remember that's a million minus a half is still going to be a positive number. Those are all positives or zeros. So we can stop. And so what does this tell us? Well, it says that the max P is going to be what? 14 when, and it looks like when x1 is equal to 4, x2 equals 6, and that means s1 equals 0, s2 equals 0, and a1 equals 0. Okay. So that's using all of our definitions and everything we've done up to date. And so that will get us started. And then in a little bit, I'll kind of introduce the big M method.